stop for a moment. Think about where you are right now. You're in bed, the lights are off. Maybe you're still holding your phone, or maybe you're on the couch, wrapped in a blanket, and it's been dark outside for a while now. Wherever you are, you're here. You're safe. You're home. Now imagine never being able to go back to that place, not because someone is stopping you, not because you did something wrong, but simply because physics won't allow it, because the distance is too great, because your body couldn't survive the journey, because that door, once you step through it, closes behind you forever. This is not science fiction. This is the reality that space agencies and private companies are seriously considering as they plan to send human beings to Mars. And the question they ask themselves, quietly, in laboratory hallways, in classified documents, in closed-door meetings, is always the same one. What if they never came back? Not, what if something goes wrong? But what if never coming back is just normal? Before we go any further, though, tell me something. Where are you right now, as you're listening? What time is it there? Are you already under the covers, or are you still holding out? Stay with me a little longer, because what I'm about to tell you is one of the greatest stories our species has ever dared to imagine living. Mars is out there, right now, in this very moment. It's not impossibly far away, on a cosmic scale, strangely enough. Sometimes it comes as close as about 54 million kilometers from us. Other times it drifts to over 400 million. It all depends on where we each are in our paths around the sun, like two people riding different carousels, crossing paths only every so often. When the orbits come close enough, a window opens. Engineers call it a launch window, a period of a few weeks, roughly every 2 years, when leaving actually makes energetic sense. Outside that window, the fuel required would be enormously greater, and the travel time would stretch beyond any reasonable limit. The journey itself, under the best conditions, takes somewhere between 6 and 9 months. 6 months in space, inside a capsule, without real gravity, exposed to cosmic radiation, with limited resources, with Earth shrinking day by day into nothing more than a bright dot among millions of other bright dots. And when you arrive, you don't find warmth, you don't find air, you don't find water on the surface. You find a red desert, silent, with atmospheric pressure so low that your blood would boil if you stepped outside without a suit. You find dust storms that can last for months. You find an average temperature of around minus 60 degrees Celsius. And yet, someone wants to go. Someone, in fact, wants to go knowing they might never come back. And perhaps the most extraordinary thing of all is that there are people willing to accept that, not in a tragic way, not as some heroic sacrifice, but almost with a certain quietness, as if that were, for them, simply the right thing to do. Tonight I'll tell you their story, and the story of Mars, and the story of us, as a species, who have always walked toward the horizon, even when we had no idea what was waiting on the other side. Let the thoughts of the day go. Breathe slowly. We've only just begun. To understand why coming back from Mars is so difficult, you first need to understand one simple thing. Space is not a place you can move through freely, coming and going as you please. On Earth, if you leave and want to return, you simply reverse course. You get in the car, make a U-turn, go home. Even on a plane, more or less, it works the same way. You decide to go back, you book a flight, you return. In space, things work very differently, much more differently than most people realize. To move through space, you can't just have an engine and decide where to go. You have to follow precise trajectories shaped by the gravity of planets, by initial velocity, by the relative positions of celestial bodies. These trajectories are called transfer orbits. The most efficient one, called the Hohmann transfer, is a kind of elliptical curve that connects Earth's orbit with Mars's orbit. The problem is that this curve only works at certain moments. Only when Earth and Mars are in the right position relative to each other, and as we mentioned, that position comes around roughly every 26 months. So if you arrive on Mars and something goes wrong, you can't simply call for help and expect it to arrive quickly. You can't come home whenever you feel like it. You have to wait for the next window, and the next window might be more than 2 years away. That alone is enough to understand that going to Mars is nothing like going on a trip. But there's more. There's a problem that engineers call delta V. Delta V is the change in velocity needed to move from one point to another in space. To travel from Earth to Mars, you need a certain delta V. To come back from Mars to Earth, you need another one. And the one for the return journey is enormous, because Mars has gravity, even if it's weaker than Earth's, about 1/3 of ours. To escape from Mars, you have to accelerate enough to overcome that gravity. You have to carry the fuel to do it. But that fuel has weight, and the more weight you carry, the more fuel you need to move it. It becomes a vicious cycle. Current estimates suggest that for a round-trip mission, the fuel needed for the return would have to be produced on Mars itself, not brought from Earth, simply because carrying all of it from the beginning would cost too much in terms of weight and resources. And how do you produce fuel on Mars? By using the Martian atmosphere, which is made up of almost entirely carbon dioxide. Through a chemical process called the Sabatier reaction, it's possible to combine carbon dioxide with hydrogen to produce methane and water. The methane can be used as rocket fuel. The water can be split into hydrogen and oxygen. It almost sounds simple, said like that. But it means building a fully functioning chemical plant on Mars, before humans even arrive, sending it ahead, waiting for it to produce enough fuel, and only then sending the crew, knowing the propellant for the trip home is already there waiting for them. NASA is already planning for this. They call it ISRU, in-situ resource utilization. It's one of the pillars of any human Mars mission. And a small technological demonstration of this principle has already taken place, with MOXIE, an experiment aboard the Perseverance rover that produced oxygen from the Martian atmosphere for the very first time in history. It was a small amount, just a few grams, but it was proof that it can be done. What we still don't know, though, is whether we'll actually be able to build all of this in time, reliably, on a planet no human foot has ever touched. And what we know even less is what happens to the human body after 2 or 3 years on Mars. What happens to the mind? What happens to something deeper? Something harder to measure? Those are the real problems, the ones no chemical plant can solve. And those are exactly what we'll explore together, slowly, without rushing, over the next while. Let yourself be carried. There is a list somewhere, a real list, kept by researchers, psychologists, and mission planners. It doesn't have a dramatic name, it's not classified, but what's written inside it is, in its own quiet way, one of the most unsettling collections of facts ever assembled about the human body. It's a list of everything that starts to break down when you take a person out of the environment they evolved in, and put them somewhere else entirely. We tend to think of the human body as tough, and in many ways, it is. It survived ice ages, it crossed oceans on wooden boats, it climbed mountains without oxygen tanks. But all of that happened on Earth. All of that happened inside a magnetic field that shields us from the worst radiation the universe throws at us. All of that happened with gravity pulling every cell, every fluid, every organ exactly where it's supposed to be. Remove gravity, and the body starts doing strange things almost immediately. Within the first hours of weightlessness, Fluids in the body shift upward. Blood and water that normally pool slightly in the legs begin moving toward the chest and head. Astronauts describe a permanent feeling of congestion, like having a mild cold that never goes away. Their faces puff slightly, their legs thin out, their sinuses stay blocked for months. This is not a minor inconvenience. The pressure changes affect vision. The optic nerve, which runs behind the eye, gets compressed. The shape of the eyeball itself can change. A significant percentage of astronauts who spend long periods in space return with measurably worse eyesight. Some of the damage appears to be permanent. Then there are the bones. On Earth, your skeleton is under constant stress. Every step you take, every time you stand up, every time you carry something, your bones respond by staying dense and strong. In space, that stress disappears, and the bones, no longer needed in the same way, begin to lose density at a rate of roughly 1 to 2% per month, depending on the individual and the countermeasures used. 6 months in space, that's potentially 6 to 12% of bone mass gone. Before you even arrive on Mars, astronauts on the International Space Station exercise for about 2 hours every single day, specifically to slow this process. Not to stop it, just to slow it. The machines they use are sophisticated, designed to simulate resistance in an environment where resistance doesn't naturally exist. And even with all of that, bone loss still happens. Muscle loss still happens. Now consider arriving on Mars after 6 to 9 months of this and immediately needing to function, needing to move equipment, needing to respond to emergencies, needing to think clearly and act quickly. With a body that has spent the entire journey quietly falling apart in ways that don't always show on the outside. The muscles are weaker, the bones are more fragile, the cardiovascular system has adapted to a lower workload and needs time to readjust to any gravitational demand at all. Balance is off. Coordination takes a while to return. On Mars, that adjustment period would happen in gravity. Real gravity. Even if it's only a third of what we feel on Earth, which is better than nothing, and Mars gravity would help the recovery process more than the zero gravity of the journey. But it also means that every stumble, every fall, every moment of disorientation happens on the surface of a planet with no hospital, no surgery centre, no way to get emergency help from anywhere. The margin for error is essentially zero, and that's just the physics of it. That's just what the body does mechanically when you take it out of the world it was built for. We haven't even touched the immune system yet. We haven't talked about sleep. We haven't mentioned what radiation does to DNA at the cellular level, quietly, invisibly, over months and years. We'll get there, but slowly, like the journey itself. There's no rushing this. For now, just let that image settle. A person floating in a capsule for 6 months, exercising every day, fighting against their own biology, trying to arrive in one piece at a place that may become their permanent home. There's something almost meditative about it, when you think about it that way, a kind of enforced stillness, a long, quiet preparation. Close your eyes for a moment if you want. Feel the weight of your own body against whatever you're lying on. That weight is a gift. It's keeping you whole. Of all the dangers waiting on the road to Mars, radiation is perhaps the most invisible, the most patient, and in some ways the most difficult to solve. On Earth, we live inside a protective shell. 2 of them, actually. The first is the planet's magnetic field, a vast invisible structure generated by the movement of molten iron deep in the Earth's core. It deflects most of the high-energy particles that stream constantly from the sun and from deep space. The second shell is the atmosphere, a thick blanket of gas that absorbs and scatters what gets through. Together, They make the surface of the Earth one of the safest places in the solar system to live. We don't notice this protection because we've never had to live without it. Leave Earth, and both shells disappear almost immediately. In the space between Earth and Mars, a spacecraft and everyone inside it would be exposed to two main types of radiation. The first is solar particle events, bursts of high-energy protons released by the Sun during solar flares and coronal mass ejections. These events can be intense and fast-moving. They can deliver a significant dose of radiation in hours. The second type is galactic cosmic rays. These are particles, mostly protons and heavier atomic nuclei, that come not from our Sun but from outside the solar system entirely. Some of them originate in supernova explosions, the violent deaths of stars in distant galaxies. They travel at close to the speed of light, and they pass through almost everything. Ordinary shielding, the kind you'd use against X-rays or gamma rays, doesn't work well against galactic cosmic rays. In fact, adding thick layers of certain materials can make things worse, because when these high-energy particles hit dense matter, they can produce secondary particles, a kind of radiation spray that spreads the damage rather than stopping it. Water and polyethylene are among the better shielding materials currently known. The most practical solution proposed so far is to line the sleeping quarters of a spacecraft with water tanks. Since the crew needs to carry water anyway, it offers some protection while serving a second purpose. But some protection is the key phrase. Not complete protection, not even close. The total radiation dose a crew would receive during a round trip to Mars, based on measurements taken by NASA's Curiosity rover during its own journey, is estimated at around 660 millisieverts. To put that in perspective, the annual radiation limit for nuclear industry workers in most countries is 20 millisieverts per year. A single CT scan of the chest delivers about 7 millisieverts. The round trip to Mars, not counting time on the surface, would expose each crew member to the equivalent of roughly 33 years of the maximum allowed occupational dose. NASA currently sets a career limit for astronaut radiation exposure. The exact number has been adjusted over the years and involves complex calculations based on age, sex, and individual risk factors. But the core issue remains: a Mars mission, with current technology, would likely push some crew members to or beyond that limit in a single trip, and the consequences are not immediate. That's the cruel nature of radiation damage. It accumulates silently. It increases the lifetime risk of cancer, particularly lung cancer, leukemia, and certain gastrointestinal cancers. It may affect the central nervous system in ways that are still being studied, potentially accelerating cognitive decline or affecting memory and decision-making years after exposure. Some researchers have observed that high-energy particle radiation causes measurable changes in the brains of mice, affecting their behavior and reducing their ability to learn new tasks. These are animal studies, with all the limitations that implies, but they raise questions that no one has fully answered yet. What happens to a human mind after months of slow irradiation in a metal capsule, millions of kilometers from home? We don't know, not really. We have models and extrapolations and educated guesses. But the honest answer, the one that keeps some scientists awake at night, is that we simply haven't done this before. There have been proposals for active magnetic shielding, technology that would generate an artificial magnetic field around the spacecraft, mimicking what the Earth does naturally. The physics is theoretically sound. The engineering challenges are enormous. No such system has ever been tested in deep space. So for now, the crew going to Mars would carry the radiation with them in their cells, in their DNA, like a slow tax that the universe collects for daring to leave. And yet, knowing all of this, People are still volunteering, still training, still dreaming about that red horizon. There's something in that, worth sitting with for a moment. The willingness to accept a cost you can't fully calculate, for something you believe is worth it. Let that thought drift with you as your breathing slows. We're moving deeper now. The story's just beginning to open up. There is a moment that every astronaut who has ever gone to space describes in some form. It happens at different times for different people, sometimes on the first day, sometimes weeks in. But it always happens. They look out the window and they see the Earth getting smaller, not in a dramatic way, not all at once. It shrinks gradually, the way a light fades when you walk away from it. The continents, once recognizable, blur into colour. The blue deepens. The white of the clouds becomes a soft smear. And then, after enough time and enough distance, it becomes a dot, a pale, luminous dot, hanging in a blackness so complete it doesn't feel real. Astronauts on the International Space Station are still close enough that Earth fills a large part of their view. They orbit at about 400 kilometres above the surface. From there, the planet looks enormous, curved, overwhelming in its beauty. Many of them describe a profound shift in perspective that happens almost instantly. A feeling of smallness, but not in a frightening way. More like being reminded of something important that you'd forgotten. Psychologists who study this phenomenon have given it a name. They call it the overview effect. It's a cognitive shift, a change in the way the mind processes the idea of home, of borders, of human conflict, of what matters and what doesn't. Astronauts who experience it often return to Earth as different people, quieter in some ways, more patient, more aware of how fragile and precious the thin blue line of the atmosphere actually is. But the crew going to Mars won't have that view for long. Within weeks of departure, Earth will no longer dominate the window. It will shrink to the size of a bright star, then a faint star, then something you have to look for deliberately. And Mars, for months, won't look like much either. Just another point of light, growing almost imperceptibly brighter as the weeks go by. For a long stretch of the journey, there will be nothing dramatic to see at all, just blackness, just stars that don't move because they're too far away to show any parallax, just the interior of the spacecraft, the same walls, the same equipment, the same faces of the same crewmates, day after day after day. This is the psychological challenge that mission planners worry about perhaps more than any other. Not the launch, not the landing, not even the radiation. The middle, the long, featureless middle of the journey, where there is nothing to do but wait, and where the mind, without enough novelty and stimulation, can start to turn on itself. Researchers study this by looking at analogous environments, Antarctic winter overstations, where small teams of people are confined to a base for months in darkness and extreme cold, with no possibility of evacuation. Submarine missions, long-duration isolation experiments conducted by space agencies, where volunteers spend up to 520 days in a sealed facility simulating a Mars mission, without ever going anywhere. What they find is consistent. After the initial excitement fades, and it always fades, a kind of flatness sets in. Motivation drops, sleep becomes irregular, minor irritations between crewmates grow into significant sources of tension. People become quieter, more withdrawn. Some experience symptoms of depression. Some experience what researchers call third quarter phenomenon, a notable dip in morale and performance that tends to occur in the final portion of an isolated mission, when the end is visible but still far away. On a Mars mission, the third quarter of the outbound journey would place the crew somewhere in the outer reaches of the journey, perhaps 5 or 6 months in, with Mars still weeks away. Earth now a faint memory of light behind them, the sense of betweenness, of being neither here nor there in every possible meaning of the phrase, and communication with home won't help the way you might hope. At its closest, Mars is about 3 light minutes from Earth, at its farthest, over 20. That means a message sent from the spacecraft could take anywhere from a few minutes to 40 minutes to arrive on Earth. And the reply takes just as long to come back. There are no phone calls, no video chats in real time, no reaching out in a moment of distress and hearing a familiar voice answer immediately. Just recorded messages, sent into the void, and a long wait for a response that arrives like a letter from someone far away. The crew will be, in a very real sense, the most isolated human beings in the history of our species, and that isolation doesn't end when they land. It deepens. Because Mars will not feel like arrival, not in the way we romanticize arrival. There will be no crowd, no ceremony, no smell of rain or coffee or anything living. There will be a landscape of extraordinary desolation, and the knowledge that everything needed to survive must come from inside that suit, inside that habitat, inside that small circle of people who made the journey together. Home will be a structure no bigger than a bus, at first, and outside that structure, nothing that has ever wanted you to live. Let that image sit gently in your mind, not with fear, but with a kind of quiet awe. Because the people willing to face all of that are not reckless, they are not unaware. They have thought about it more carefully than almost anyone, and still they say yes, breathe. You're still here, still safe, still exactly where you're supposed to be. Somewhere in a desert, right now. A group of people is pretending to live on Mars, not metaphorically, not as an art project, as a serious scientific exercise designed to answer questions that can't be answered any other way. Questions about how human beings actually behave when they're confined, isolated, dependent on each other, and cut off from the rest of the world for extended periods of time. These facilities are called Mars Analog Habitats. They exist in several locations around the world, chosen specifically because their environments resemble, in some partial way, the conditions of Mars, the Utah desert, the slopes of a Hawaiian volcano, the Canadian Arctic, Antarctica. The people who volunteer to live in them agree to strict protocols. They don't step outside without wearing simulated spacesuits, even though there's breathable air just beyond the door. They communicate with the outside world only through delayed messages, mimicking the communication lag of an actual Mars mission. They grow some of their own food. They conduct scientific experiments. They manage equipment failures and interpersonal conflicts and medical situations without outside assistance. And researchers watch. They collect data on sleep quality, cognitive performance, emotional states, group dynamics, physical health. They analyze how decisions are made under stress. They study how leadership emerges and evolves. They look at what happens when two people stop getting along in a space where there is nowhere else to go. One of the most significant programs of this kind is run by NASA itself. It's called HERA, the Human Exploration Research Analog. Another, run at the University of Hawaii, is called HISEAS, Hawaii Space Exploration Analog and Simulation. Crews have lived in a dome on the slopes of Mauna Loa for periods ranging from 4 months to a full year, following Mars mission protocols as closely as possible. What comes out of these studies is both reassuring and sobering in equal measure. The reassuring part: human beings are remarkably adaptable, given structure, purpose, and good team selection. People can function effectively in extreme isolation for long periods. They find rhythms, they create rituals, they build bonds with crewmates that often become among the deepest relationships of their lives. There is something about shared hardship, shared purpose, and shared beauty, even the strange beauty of a simulated Mars habitat that brings people together in ways that ordinary life rarely does. The sobering part, it is never easy, and the factors that determine whether a crew thrives or fractures are surprisingly subtle. Technical competence matters, of course, but it turns out that the most important factor in long-duration isolation is not intelligence or physical fitness or even emotional stability in isolation, it's interpersonal compatibility. The ability to communicate without escalating, the ability to tolerate irritating habits in others without letting resentment accumulate, the ability to give and receive feedback in a way that doesn't damage relationships that cannot be replaced. One study found that the most common source of serious conflict in isolated groups wasn't workload or danger or even boredom. It was noise, specifically the sounds other people make while sleeping, eating, or going about their routines. Small things, made enormous by proximity and repetition and the absence of escape. Imagine that. 6 to 9 months in a spacecraft. The same sounds every night. And then years on a planet, in a habitat, with the same people, and no possibility of simply taking a walk somewhere else to clear your head. Mission planners take crew selection extraordinarily seriously as a result. The psychological screening for a Mars mission would be the most rigorous in the history of human spaceflight. Not just looking for people without problems, but looking for people with very specific combinations of traits that tend to work well together under pressure, for very long periods, in very small spaces. There are also proposals for dedicated conflict resolution protocols, structured processes that crews would follow when disagreements arise, before they become crises, trained mediators on Earth, available via delayed communication, pre-agreed rules about decision-making authority, about rest periods, about privacy, however limited privacy can be in a habitat the size of a small apartment. Because on Mars, a conflict that goes unresolved doesn't just make the mission unpleasant, it can make it fatal. The human element, in the end, may be the most complex system of all, more unpredictable than rocket engines, more difficult to test than life support, more prone to failure in ways that no amount of engineering can fully anticipate. And yet, every analog mission that has been completed has also produced something unexpected, something the researchers didn't fully predict. A sense of meaning, a depth of experience that participants describe, almost universally, as one of the most significant things they have ever done, even in a simulation, even knowing they could walk out the door. Imagine what it would feel like, for real. Your body is heavy now, in the good way, the way it gets when the day has finally finished asking things of you. Let it be heavy. Let the story carry you the rest of the way. We're moving deeper into this together. There is a word that comes up again and again in the literature about Mars missions. It appears in psychological studies, in philosophical essays, in the private journals of astronauts, in the transcripts of interviews with people who have spent months in isolation. The word is grief, not the grief of loss in the traditional sense, not the grief of someone dying or something ending, but a quieter, more diffuse kind of grief. The grief of distance, the grief of knowing that everything you love is unreachable, not forever necessarily, but for long enough that the distinction starts to feel meaningless. Psychologists have a term for it. They call it chronic sorrow, or sometimes ambiguous loss. It's the emotional weight of being separated from something that still exists, that hasn't gone anywhere, but that you simply cannot reach. Parents who have children with long-term illnesses sometimes describe it. People who have loved ones with dementia describe it. The thing you love is still there, but the connection to it has been severed in a way that ordinary grief rituals don't quite address. For the crew of a Mars mission, that thing would be everything, every person they have ever known, every place they have ever been, every ordinary comfort of a life lived on Earth. The smell of a specific kitchen, the sound of a city at night, the feeling of wind, real wind, not recycled air pushed through a ventilation system, but actual moving atmosphere, carrying pollen and moisture and the faint traces of somewhere else. These are not small things. They are the texture of a life, and on Mars, they would all be gone. Researchers who study astronaut psychology talk about something called the Earth out of view phenomenon. It's been observed that there is a psychological threshold, not precisely located but clearly felt, that occurs when Earth is no longer visible to the naked eye. Before that moment, even in deep space, there is still a visible anchor, a blue light in the darkness, proof that home exists, that it's real, that it's still there. After that moment, something shifts. The connection feels different, more abstract, more fragile. Some astronauts in simulation studies report a change in their emotional state that correlates directly with this loss of visual contact. A subtle but measurable increase in anxiety, a feeling of exposure, as if a safety net had been quietly removed. On a real Mars mission, Earth would fade from naked eye visibility within the first weeks. For the remainder of the journey, and for the entire stay on Mars, it would exist only as a point of light, indistinguishable from a star unless you knew exactly where to look. Mission designers have proposed various ways to address this. Carefully curated personal memory archives, collections of photos, videos, voice recordings, familiar music, ambient sounds from places that matter to each crew member, not to replace what's missing, but to create a sensory bridge across the distance. Something to hold on to when the gap feels too wide. Some researchers have gone further, suggesting that the psychological preparation for a Mars mission should include deliberate grief work before departure, not as a morbid exercise but as a practical one, acknowledging consciously what will be lost, sitting with that loss, finding a way to carry it without being crushed by it before the mission even begins, because the alternative, pretending the loss isn't real, pretending that video messages and photo archives are a sufficient substitute for physical presence, may be more damaging in the long run than honest acknowledgement. There is a strange comfort in that idea, actually. The idea that grief, properly attended to, becomes not a wound but a kind of anchor, that missing something deeply is itself a form of love, and that love, carried consciously, can sustain a person through almost anything. The astronauts and mission candidates who speak most calmly about the prospect of not returning are often the ones who have thought most carefully about what they would be leaving. They don't minimize it, they don't pretend it doesn't matter, they hold it clearly, and they choose anyway. That kind of clarity, that kind of deliberate acceptance, is rare. It takes a particular relationship with one's own inner life, a willingness to look directly at hard things without flinching, and then to keep moving. It's the same quality, in its own way, that makes a good navigator, not the absence of fear, but the ability to feel it fully and still read the stars. You might know that feeling, the feeling of choosing something difficult because it matters, of walking towards something that costs you, because the alternative costs you more. Let that thought be soft, let it float. Outside, the night is doing what it always does, holding everything gently in the dark. Mars has 2 moons. Their names are Phobos and Deimos, fear and dread in ancient Greek. They were named by the astronomer Asaph Hall in 1877, who found them after nearly giving up the search. His wife, Angelina, convinced him to try one more night, and on that last night, he found them both. There is something quietly poetic about that. The moons of Mars, discovered on the night someone almost stopped looking. Phobos is the inner moon, the larger of the two. It orbits Mars so closely and so quickly that it completes a full orbit in less than 8 hours. That means it rises in the west and sets in the east, moving opposite to the direction of Mars's rotation, crossing the sky multiple times in a single Martian day. From the surface, it would appear to move visibly, noticeably, like a fast-moving star that changes direction. Deimos is smaller, farther out, and much slower. It takes about 30 hours to complete its orbit. From the surface of Mars, it would look like a slightly brighter star, barely distinguishable from the others except that it moves, slowly, across the sky over the course of the night. Neither moon is spherical in the way Earth's moon is. Phobos is lumpy, irregular, pocked with craters, the largest of which, named Stickney, is nearly half the diameter of the moon itself. Scientists believe it was formed either by a captured asteroid or by debris from an ancient impact on Mars. Its future is already written. In the slow language of orbital mechanics, Phobos is spiraling inward. In about 50 million years, it will either crash into Mars or break apart into a ring. Deimos, moving in the opposite direction orbitally, is slowly drifting away. Like Earth's moon, though far more slowly, it will eventually escape Mars's gravity altogether. For the crew on Mars, these moons would be part of the daily sky. Small, strange, moving in ways that would take some getting used to, but they would be there, overhead, reliable, and in a sky where everything else is unfamiliar. There is something grounding about reliable things overhead. The Martian sky itself would be a constant source of strangeness. During the day, it would not be blue. The fine dust suspended in the thin atmosphere scatters light differently than Earth's thicker air does. The daytime sky on Mars is a pale butterscotch, a muted orange-pink that shifts toward violet near the horizon. At sunrise and sunset, the colours invert in a way that feels almost wrong to human eyes. The sky near the sun glows blue, while the rest fades to red. The sun itself would appear smaller, about 2/3 the size it appears from Earth, still bright enough to require eye protection, but clearly diminished. A smaller star, in a stranger sky. Nights on Mars would be extraordinary. The atmosphere is thin enough that the stars would be sharper, brighter, more numerous than anything visible from Earth's surface. The Milky Way would arc overhead in full clarity, not washed out by atmospheric haze or light pollution. In the complete silence of the Martian surface, with no wind noise, no animals, no distant traffic, no any of the constant background hum of a living planet, those stars would feel very close. Astronauts would spend time outside only in pressurized suits, but even through a helmet visor, standing on red ground under that sky, the experience would be unlike anything a human being has ever felt. The closest analogue anyone living has ever had is standing in a very remote desert on a very clear night. But even that is nothing like Mars, because even the most remote desert on Earth is unmistakably alive. The soil moves, the air carries things, something somewhere is breathing. On Mars, nothing breathes, nothing moves except the dust when the wind picks up and the slow mechanical arc of Phobos crossing the sky. There is a kind of beauty in that stillness, an ancient, uninterrupted stillness that has been there for billions of years and will be there long after any human presence has ended. A silence so complete it has its own texture. The people who go to Mars will learn to live inside that silence, to find it not oppressive but profound, to look up at a sky that no human eye has ever seen from below, and feel something that doesn't have a name yet, Some experiences arrive before the language for them does. The first people on Mars will spend years living in feelings that won't have words until they come home. If they come home. Your breath is slower now. The images are softer. The distance between thoughts is growing. That's exactly where we want to be. Long before anyone sets foot on Mars, the planet will have already been shaped by human hands. Not dramatically, not visibly from space, but in the places that matter, in the specific coordinates chosen after years of analysis, in the subsurface layers probed by radar and rover, in the atmospheric readings taken by a dozen different instruments over decades. The groundwork will have been laid, a kind of invisible architecture built from data and decisions, waiting for the people who will one day inhabit it. This is the philosophy behind what space agencies call a pre-deployed mission architecture. The idea is straightforward in concept, even if the execution is staggeringly complex. You send the equipment first, long before the crew departs Earth. Cargo missions deliver the habitat, the power systems, the life support infrastructure, the fuel production plant, the reserve supplies. Everything needed to survive is already on Mars, already tested, already running, by the time human feet touch the ground. The logic is compelling. A crew arriving on Mars to find their habitat already inflated, their oxygen already being produced, their return fuel already stored, is in a fundamentally different situation than a crew arriving to set everything up from scratch. The difference between those two scenarios is measured not just in convenience, but in survival probability. SpaceX has published plans for this approach with their Starship vehicle. The concept involves sending multiple uncrewed cargo flights to Mars during a launch window, establishing a basic infrastructure, and then sending humans in the following window 2 years later. NASA's own planning documents describe similar sequencing, with the addition of robotic systems that would begin construction and testing of critical systems long before human arrival. But pre-deployment introduces its own category of problems. Chief among them is the question of what happens when something breaks, and you're not there to fix it. Machinery left unattended on Mars for 2 years is machinery subject to everything Mars can throw at it. Dust accumulation, which is not trivial on a planet where storms can cover the entire globe and last for months. Temperature cycling, with days and nights that swing by more than 100 degrees Celsius in some locations, stressing every joint and seal and electronic component repeatedly over hundreds of cycles. Radiation, degrading materials and electronics at the surface level. Robotic maintenance systems are part of the proposed solution. Rovers and automated repair units that could address basic failures, replace components, clear dust from solar panels. But robotics on Mars operates under the same communication delay that affects everything else. Instructions sent from Earth arrive minutes later, and the robots themselves are limited in the complexity of tasks they can perform without direct human oversight. There is a real possibility, perhaps even a likelihood, that a crew arriving on Mars would find some portion of their pre-deployed equipment in a degraded or failed state, not necessarily catastrophically, but enough to require improvisation, enough to require solving problems under pressure with limited tools in an environment that punishes mistakes. The people selected for this mission will need to be, among many other things, exceptional improvisers, not just trained for the expected, but genuinely comfortable with the unexpected, with finding solutions using what's available rather than what was planned for, with staying calm when the plan and the reality diverge, which on Mars they almost certainly will. There's a term used in engineering and in military planning, and increasingly in space mission design. It's called graceful degradation. The idea that a well-designed system, when something fails, doesn't collapse entirely but instead steps down to a reduced but still functional state. Each failure is contained, each backup has a backup, the whole thing bends without breaking. The habitat designs being developed for Mars are built around this principle. Modular structures where one section can be sealed off if it fails without compromising the others. Life support systems with multiple redundancies, so that no single point of failure can be immediately fatal. Power systems that can operate at reduced capacity if some components fail, maintaining the most critical functions while others are repaired. But graceful degradation has a limit. There is a point beyond which reduction becomes collapse, and on Mars, far from any resupply, far from any rescue, the distance between manageable degradation and unrecoverable failure is shorter than anywhere else human beings have ever tried to live. The planners know this, the engineers know this, and the people who will one day step off a spacecraft onto that red ground know it too. They will have trained for years in simulated emergencies, practiced every conceivable failure scenario until the responses are automatic, studied the systems they depend on until they understand not just how to operate them but why they work, so that when something behaves unexpectedly they can reason from first principles rather than just following a checklist. But preparation, however thorough, can only go so far. At some point, on Mars, something will happen that no one prepared for. And in that moment, the mission will depend not on training, but on character, on the particular quality of mind that stays clear when everything is unclear. That finds the next step when the path has disappeared. That quality cannot be engineered. It can only be recognized in the people who already have it and trusted. The night deepens around you. Your thoughts are slower now, less sharp, more like shapes than sentences. That's good. That's exactly right. Water is the thing that makes life possible. On Earth, we know this so well that it has become almost invisible to us. We turn a tap and there it is. We walk outside after rain and it's everywhere, soaking into soil, running down streets, sitting in puddles that reflect the sky. On Mars, water is the central obsession, the question around which almost every other question orbits. There is water on Mars. That much is now established beyond reasonable doubt. But it is not the water of rivers and lakes and easy availability. It is water in forms that require effort, ingenuity, and energy to access, and understanding where it is, how much there is, and how to reach it, is one of the most active areas of Mars research currently underway. The most accessible form of water on Mars is ice. Near the poles, there are permanent ice caps composed of a mixture of water ice and dry ice. Frozen carbon dioxide. The southern polar cap contains a significant amount of water ice buried beneath a layer of carbon dioxide ice that varies with the seasons. The northern polar cap is largely water ice, exposed more directly. But the poles of Mars are not ideal locations for a human settlement. They are cold even by Martian standards. The available sunlight for solar power generation is limited and seasonal, and the logistics of polar operations on a planet with no existing infrastructure are daunting. More promising for a first settlement are the mid-latitude regions, where water ice has been detected just below the surface, sometimes only a meter or two down. Images from orbiting spacecraft have shown fresh impact craters on Mars where the collision excavated subsurface ice, briefly exposing it before it's sublimated in the thin atmosphere. These exposures give scientists precise data about where the ice is, how deep and how pure. Extracting that ice would involve drilling or excavating, melting it, purifying it, and then deciding how to use it. Water has multiple roles in a Mars mission. Drinking water, of course, but also water for growing food in hydroponic systems. Water as a source of oxygen, split by electrolysis into hydrogen and oxygen, and water as a component of rocket fuel. Through the Sabatier process we talked about earlier, every litre of water extracted from Martian soil is a litre that didn't have to be carried from Earth. And the economics of that difference in terms of mission mass and cost are enormous. There is also the possibility of liquid water deeper underground. The Marsis radar instrument aboard the Mars Express orbiter detected what appears to be a subglacial lake beneath the southern polar ice cap, about 20 kilometres across, sitting under approximately 1.5 kilometres of ice. The debate about whether this detection represents liquid water or some other phenomenon is still ongoing among scientists. But the possibility is real, and if confirmed, it raises implications that go far beyond logistics, because liquid water, even cold, even salty, even buried under a kilometre of ice, is a potential environment for life. Mars was not always the frozen desert it is today. Between 3 and 4 billion years ago, in a period called the Noachian, the planet had a thicker atmosphere, a warmer climate, and liquid water on its surface. River valleys are still visible in the Martian terrain, carved by water that flowed for millions of years. Ancient lake beds have been identified, their sedimentary layers recording a time when conditions on Mars were, in some limited ways, not entirely unlike conditions on early Earth. Whatever happened to that water? Most of it was lost to space as Mars's magnetic field weakened and its atmosphere was slowly stripped away by the solar wind. Some of it froze, some of it may have retreated underground, and if life ever arose on Mars during that warmer, wetter period, it may have retreated underground too, following the water, as life on Earth follows water wherever it goes. The search for signs of ancient life, or even current microbial life, in the subsurface of Mars is not a fringe idea. It is a central objective of multiple active missions. The Perseverance rover is collecting rock samples specifically chosen for their potential to preserve biosignatures, evidence of past biological activity at the molecular level. Those samples are intended to be returned to Earth by a future mission for analysis in laboratories far more sophisticated than anything that can be sent to Mars. If those samples contain evidence of life, even ancient, even microbial, the implications would be staggering. It would mean that life is not unique to Earth, that the chemistry of life, given the right conditions, arises naturally, that the universe is, in some fundamental sense, alive, and it would transform the question of human settlement on Mars into something much more complicated. Because if Mars hosts life, even simple life, even fossils of life, the ethics of introducing Earth organisms into that environment becomes genuinely thorny. Every human being carries trillions of microorganisms. Every surface touched by a human hand introduces biological material. The contamination question, already taken seriously in current robotic missions, would become an entirely different order of problem with a human crew. This tension between the human need to go and the scientific imperative to preserve is one of the unresolved conversations at the heart of Mars exploration. It doesn't have a clean answer. It probably won't for a long time. But the water is there, in ice and impossibility, waiting at various depths beneath a surface that looks barren but maybe, in its own ancient and quiet way, anything but. The images blur softly now. The ideas are less sharp, more felt than thought. Water on Mars, ice beneath the red dust, somewhere underground, perhaps, something that was once alive. Let it all settle into the dark behind your eyes. Food is one of those things that only reveals its full importance when it becomes a problem. On Earth, eating is so woven into daily life that it functions as background. You get hungry, you find something, you eat it. The process is rarely complicated and rarely precious. A sandwich is just a sandwich. A bowl of rice is just a bowl of rice. You eat, you move on, you don't think much about it until the next time hunger arrives. On Mars, food becomes something else entirely. It becomes a system, a carefully engineered, meticulously planned, mission-critical system upon which everything else depends. And the challenge of feeding a small crew on another planet for years at a time without resupply is one of the most practically demanding problems in the entire architecture of a Mars mission. The first and most obvious challenge is mass. Every kilogram sent to Mars from Earth costs an enormous amount in fuel and logistics. Early estimates for a Mars mission suggested that food alone, if carried entirely from Earth for a multi-year stay, would constitute one of the largest portions of the total mission mass. Pre-packaged food that lasts years, without refrigeration, that provides complete nutrition, that doesn't degrade significantly over a journey lasting the better part of a year, is heavy, and there's a lot of it needed. NASA has been developing and refining space food technology for decades. The food eaten by astronauts on the International Space Station is significantly better than what early space travelers had access to, but it is still fundamentally processed, packaged, and calorie-dense in ways that prioritize shelf life and mass efficiency over experience. Astronauts on the ISS frequently describe food as one of the primary sources of both comfort and frustration. When a fresh fruit or vegetable arrives on a resupply mission, it is treated as an event, a small celebration, something to be divided carefully and savoured. On Mars, resupply missions would not arrive regularly. The logistics of sending cargo to Mars mean that the crew would need to be largely self-sufficient in food production for the duration of their stay. And self-sufficient food production on Mars means growing things. The concept is called bioregenerative life support. Instead of relying entirely on stored food, the crew would cultivate plants inside the habitat, using artificial light, carefully managed soil or hydroponic growing systems, recycled water, and carbon dioxide from the habitat atmosphere. The plants would do multiple things simultaneously. They would produce food, they would absorb carbon dioxide and release oxygen, contributing to atmospheric management, and they would provide something that no prepackaged meal can replicate, something that mission psychologists consider nearly as important as the calories themselves. They would provide life, growing things, colour, the smell of soil and green leaves in an environment otherwise defined by metal and recycled air and the same walls every single day. Studies conducted on the psychological effects of plant cultivation in isolated environments show consistent results. Access to growing plants reduces stress markers. It improves mood. It gives people a sense of agency and continuity, something living to tend, something that responds to care with visible growth. In environments where so much is controlled and synthetic, a tomato plant flowering under an artificial sun carries a weight of meaning that goes well beyond nutrition. The crops most study for Mars cultivation are chosen for specific qualities: high calorie density, rapid growth cycles, tolerance for the controlled conditions of a habitat. Potatoes are frequently cited, famously, for their caloric efficiency per square metre of growing space. Leafy greens grow quickly and provide micronutrients. Soybeans offer protein and fat alongside carbohydrates. Wheat, though slower, provides the basis for bread, which carries its own psychological significance, its own deep association with home and normalcy. But growing food on Mars is not as simple as putting seeds in soil and waiting. The Martian regolith, the surface material, is not soil in any meaningful sense. It contains perchlorate, toxic compounds that would need to be removed or neutralized before the material could support plant growth. It lacks the organic matter and microbial communities that make Earth soil alive and fertile. Creating genuine growing medium on Mars would require importing organic material, building microbial communities deliberately, processing the regolith to remove toxins, and managing the whole system with the same care given to any other life-critical system on the mission. Because it is life-critical, in every sense. There are proposals for closed-loop agricultural systems, where waste from the crew, including organic waste, is composted and returned to the growing medium, where water is recycled through the plants and back into the system, where nothing is discarded that can be reused. These systems exist in prototype form on Earth, tested in analog environments and research facilities. None of them are yet efficient enough or reliable enough for the demands of a real Mars mission. But they're getting closer. Every iteration improves. Every failure teaches something, and the researchers working on these systems tend to share a particular quality of mind, a kind of patient, practical optimism that understands problems as temporary states on the way to solutions. The first meal grown and eaten on Mars will be, by any reasonable measure, one of the most significant meals in human history. Not because it will taste extraordinary. It almost certainly won't. At first, the crops will be basic, the preparation options limited, the kitchen nothing like what the crew left behind on Earth. But it will mean something else. It will mean that humans are not just visiting Mars, not just surviving there on borrowed resources. It will mean that Mars is beginning, however tentatively, however partially, to feed them. That the relationship between people and planet has begun, the first fragile thread of a connection that, if everything goes right and much goes wrong and people persist through all of it, might one day become a civilization, a thin thread, but a real one. The warmth of that image is a good thing to carry into sleep, something growing, something tended, something alive in all that red silence. Let it grow slowly in the dark. There is a document that exists in various forms across multiple space agencies and private spaceflight companies. It doesn't have a single official title. In some organizations, it's called a contingency protocol. In others, a mortality framework. In the quieter internal conversations, people sometimes just call it the hard document. It addresses a question that no one particularly wants to ask out loud, but that responsible mission planning cannot avoid. What happens when someone dies on Mars? This is not a morbid digression. It is a practical reality that every serious Mars mission architecture must address, because the probability of someone dying during a multi-year mission to another planet, given everything we've discussed, is not negligible. It is, in fact, considered by many mission planners to be close to a certainty over a long enough time frame. The causes could be many. Medical emergency, the kind that requires surgery or intensive care that simply cannot be provided in a Mars habitat. A suit failure during an extravehicular activity. Exposure to the Martian atmosphere even briefly would be fatal. An accident during construction or equipment operation. A slow medical decline related to radiation exposure, to bone loss, to an immune system weakened by years in a closed environment. On Earth, when someone dies, there are systems, there are professionals, there are rituals that societies have developed over thousands of years to help the living process the death of someone close. There is separation from the body, which is handled by others. There is community, the gathering of people who also knew the person, who can share the weight of loss together. On Mars, none of those systems exist. The crew would be alone with the death of their colleague, alone in a small habitat, with no possibility of outside support, with a body that would need to be dealt with practically, because a Mars habitat has no capacity for a traditional burial or any of the rituals that make death bearable in ordinary life. Proposals have been made. EVA suits could serve as a kind of temporary containment. The extreme Martian environment would naturally prevent biological decomposition in the way Earth conditions would allow. In some plans, the body might eventually be placed on the surface, in a designated area, marked but not buried, preserved by the cold and the aridity and the absence of biological activity. The psychological impact on the remaining crew is something that analog mission studies have tried to address, though none have involved an actual death. Simulations have included sudden incapacitation scenarios, where a crew member is removed from the mission without warning to study how the remaining team responds. The results show, consistently, that the loss of even one crew member from a small team has profound effects on morale, on workload, on the interpersonal dynamics of those who remain. A Mars crew of 4 or 6 becomes, over months and years, something closer to a family than a professional team. The bonds formed in shared isolation, shared danger, shared beauty, are not easily replaced or restructured. The sudden absence of one of those people would create a wound in the group that would not heal quickly, and that would need to be carried alongside the continued demands of the mission. Mission psychologists recommend that crews discuss death explicitly before departure, not obsessively, not in a way that creates anxiety, but openly, acknowledging that it could happen, deciding together how they would want to be remembered, what should be communicated to family on Earth, what role each person would want their crewmates to play in marking their passing, making the unspoken spoken while there is still time and calm in which to speak it. There is wisdom in that, not just for Mars, for anywhere. The willingness to face the hardest questions while there is still room to face them calmly is one of the qualities that defines the people drawn to this kind of mission. Not an absence of fear, not a carelessness about mortality, but a clear-eyed acknowledgement that life has an ending, and that knowing this, really knowing it, changes how you inhabit the time before it. The philosopher Heidegger called this being toward death. The idea that an authentic life is one lived in full awareness of its own finitude, that the certainty of ending is not something to be denied or managed, but something to be integrated, held close, used as a compass. The people going to Mars, some of them, will die there, in conditions no human being has ever faced, far from everyone they love, under a sky no one has ever seen from below. And some of them know this, and go anyway, not because they don't value their lives, but because they value them enough to spend them on something that matters. That is not tragedy. That is a particular kind of courage, quiet and considered and entirely human. The darkness around you is soft now. The breath comes and goes without effort. Whatever you are carrying today, you can put it down. It will be there tomorrow if you need it. Tonight, just rest. There is a phrase that engineers use when they talk about the systems that keep people alive in space. They call them life support systems. The name is almost too simple for what it describes. Too clean, too clinical. Because what life support actually means, when you break it down to its components, is the continuous, uninterrupted, automated management of every single condition necessary for a human body to remain alive in an environment that would kill it instantly without intervention. On Earth, life support is invisible. The atmosphere maintains itself. The temperature, at least in most inhabited places, stays within ranges the body can tolerate. Water cycles through clouds and rivers and soil and back again without anyone managing it. The sun provides energy. The magnetic field deflects radiation. The entire planet, in a sense, is a life support system of unimaginable complexity and reliability, built over 4 billion years of geological and biological evolution. On Mars, every single one of those functions must be replicated artificially. in a structure that fits inside a rocket, operated by a small crew with limited spare parts, for years at a time, without the possibility of a technician arriving from outside to fix what breaks. The atmosphere inside a Mars habitat must be maintained at the right pressure, the right composition, the right humidity. Too much carbon dioxide and the crew begins to suffer cognitive impairment, then loses consciousness, then dies. Too little oxygen, and the same progression begins. Too dry and the respiratory system suffers. Skin cracks. Eyes ache. Too humid and mold begins to grow on surfaces, a biological threat in a closed environment. Temperature must be regulated within a narrow band. The Martian surface swings between extremes that would destroy an uninsulated structure within days. The habitat walls must insulate effectively, and the heating and cooling systems must operate continuously, adjusting to the cycle of day and night, to the position relative to the sun, to the heat generated by the crew and the equipment inside. Water is recycled to a degree that would be uncomfortable to think about too directly. On the International Space Station, the water recycling system processes urine, humidity from the air, and other wastewater back into drinking water with an efficiency that exceeds 90%. The water that astronauts drink has been through the system many times. It is, by any objective measure, cleaner than most tap water on Earth. But the psychological adjustment to knowing this takes time. On Mars, water recycling would be even more critical, because there is no external supply to draw from until the ice extraction system is operational. Every drop must be conserved and recovered. The closed-loop nature of the system means that nothing is truly wasted, everything cycles back, everything is used again. Waste management in general is a domain of life support that receives less attention in public discussions of Mars exploration, but represents one of the more demanding engineering challenges. Human bodies produce waste continuously. That waste must be processed, safely, in a way that doesn't contaminate the habitat, doesn't introduce pathogens, and ideally produces something useful. Composting systems, biodigesters, chemical processing units. The exact approach varies by proposal, but the fundamental requirement is the same. What goes in must go somewhere safe. Power is the foundation beneath all of this. Without power, nothing else works. The atmosphere processes stop, the heating fails, the water recycling shuts down, the lights go out. Every life support system requires continuous electrical energy, and that energy must come from somewhere reliable. Solar power is available on Mars, but less effective than on Earth. Mars is farther from the Sun, receiving roughly 43% of the solar energy that Earth receives per square meter. During dust storms, that number drops further, sometimes dramatically. The global dust storm of 2018, which lasted for months and eventually ended the Opportunity rover's mission by blocking all sunlight to its solar panels, is a reminder of what Martian weather can do to solar energy systems. Nuclear power, specifically small fission reactors, is considered the most reliable long-term solution. NASA has already tested a small fission surface power system called kilopower, designed specifically for planetary surface operations. It can produce up to 10 kilowatts of electrical power continuously, independent of sunlight, independent of weather, for years. 10 kilowatts sounds modest. It is roughly what a small house uses. But for a small Mars habitat with efficient systems, it represents a meaningful baseline. Multiple units, operating together, could power a more substantial settlement. The entire life support architecture, taken together, is a chain, and a chain is only as strong as its weakest link. One failed seal, one blocked filter, one software error in an atmospheric sensor, and the chain begins to weaken. The redundancies and backups are there precisely because every link will fail eventually, given enough time. The question is not whether something will break. The question is whether the system can absorb the failure gracefully, and whether the crew can repair it before the next link in the chain gives way. Living inside that chain, day after day, would require a particular relationship with technology, not the passive relationship most of us have with the systems that sustain our lives on Earth, the relationship of someone who doesn't think about where the water comes from or how the heat stays on, but an intimate, attentive relationship. The relationship of someone who knows every component by name, who listens for changes in the sound of the ventilation system, the way a sailor listens for changes in the wind, who understands that the difference between comfort and catastrophe is the difference between a working seal and a failed one. That kind of attention, sustained over years, is itself a form of work, a cognitive and emotional labour that doesn't appear in any job description but never stops. The crew on Mars will know, at all times, exactly how close to the edge they are, not in a panicked way, but in the clear-eyed way of people who have made peace with the fact that the edge exists and have learned to live competently near it. There is a quality of presence in that, a kind of aliveness that comes from knowing precisely what is at stake. Your own breath, moving in and out, is its own quiet life support system, doing its work without being asked. Trust it. Let it carry you. The question of who goes to Mars is, in some ways, the most human question of the entire enterprise. Not who is physically capable, not who scores highest on the cognitive tests, or who has the most relevant technical skills. Those things matter, of course, and they narrow the field considerably, but at the final level of selection, when you have a group of people who are all physically exceptional, all intellectually capable, all technically qualified, the question that remains is something more like, who are these people, really? And what will they be like after 2 years on another planet? The history of human exploration provides some guidance, though none of the analogies are perfect. Antarctic expeditions in the early 20th century, submarine crews during wartime, long-duration scientific stations in remote locations, these all offer data points. They tell us something about what kinds of people tend to function well in extreme isolation, under sustained pressure, with limited resources and no exit. But Mars will be beyond all of these in duration, in distance, in irreversibility. The closest analogue in human history, in terms of psychological isolation, might be the crews of sailing ships in the age of exploration, who spent months at sea with no communication with home, no certainty of return, and only each other for company. And even those journeys ended. Even the longest of them had a homecoming, eventually, for those who survived. Mars may not. The profiles that emerge from isolation research consistently favour certain traits. Not specific personalities, but specific capacities. The ability to tolerate ambiguity without becoming anxious. The ability to find meaning in routine, to invest small daily tasks with a sense of purpose, rather than grinding through them as obligations. The ability to regulate emotional states internally, without requiring constant external validation or stimulation. Curiosity appears repeatedly as a predictor of successful adaptation to extreme environments. Not curiosity as a personality type, but curiosity as a coping mechanism, the tendency, when something unexpected happens, to approach it with interest rather than fear, to ask what this means rather than why is this happening to me. On Mars, unexpected things will happen constantly. The environment is not fully characterized. No amount of orbital data and robotic reconnaissance can substitute for the experience of actually being there, with all of its sensory complexity and its capacity for surprise. The crew that thrives will be the crew that meets that surprise with open hands. There's also the question of leadership. Small isolated groups under sustained stress tend to develop strong informal hierarchies, sometimes aligned with the official command structure, sometimes diverging from it in ways that can be constructive or deeply disruptive. The person with the most formal authority is not always the person whose judgment the group instinctively trusts. And the gap between those two things, if it grows wide enough, can fracture a team at exactly the moment it most needs to function as one. Mission planners have experimented with different command structures, flat hierarchies, where decisions are made collectively, traditional hierarchies with a clear chain of command, rotating leadership, where different crew members take point on different categories of decision. None of these structures is inherently superior. Each has contexts in which it works and contexts in which it fails. What seems to matter most is not the structure itself, but the quality of the relationships within it, whether people feel genuinely heard, whether disagreement is processed in ways that strengthen rather than weaken the team, whether there is enough trust that honesty is possible, even when the honest thing is hard to say. Trust, built before departure, through shared training and shared difficulty, is the most valuable resource a crew can carry to Mars, more valuable than any piece of equipment, more critical than any protocol. Because trust is what makes the difference, in a moment of crisis, between a team that functions and a team that falls apart. There have been moments in the history of space exploration where that difference was visible, where the record shows a crew under extreme pressure making decisions with a clarity and a cohesion that, in retrospect, looks almost miraculous, and moments where the record shows the opposite, where small interpersonal failures cascaded into operational ones, where the human system failed before the technical one did. The people selected for Mars will be, in many ways, the most carefully chosen human beings in history. Not the bravest, necessarily, not the smartest, but the ones who, in combination with each other, form something greater than the sum of their individual qualities, a specific kind of human system, resilient and flexible and honest, and capable of sustaining itself under conditions no human system has ever faced. They are probably already alive, somewhere on Earth right now, going about their days, not yet knowing what they will one day be chosen for, training in adjacent fields, developing the capacities, without yet knowing why those capacities will matter. There is something quietly astonishing about that. The people who will stand on Mars and look up at a sky no one has ever seen from below are here, now, among us, living ordinary lives on the planet they will one day leave. The night holds that thought gently. No need to grasp it. Just let it drift. At some point during the mission, probably not in the first weeks and probably not announced in any formal way, one of the crew members will walk to a part of the habitat where they can be alone, or as alone as the space allows, and they will think about Earth in a way they haven't allowed themselves to think about it since departure. Not the abstract Earth, not the pale dot visible through the porthole on a clear night, but the specific, textured, irreplaceable Earth of their own life, a particular street, a particular face, the way light fell through a specific window on a specific morning that they didn't know. At the time, they were storing as something precious. This moment is not a breakdown. It is not a crisis. It is simply the arrival of something that was always coming, the full weight of the distance, settling in. Like the moment in a long journey when the tiredness stops being manageable and becomes something you have to actually feel before you can carry it further. Every person who has ever been far from home for a long time knows a version of this moment. The traveller who has been gone long enough that the excitement has faded and the novelty has worn down, and what remains is just the plain fact of absence. The soldier in a foreign country who wakes one morning and finds that the distance has become real in a way it wasn't before. The researcher at an Antarctic station in the middle of winter, when the darkness has been continuous for weeks and the next resupply is months away. On Mars, this moment would arrive against a backdrop of absolute irreversibility. Because the traveller can't book a flight home. The soldier can't request a transfer. The researcher can't decide to leave early. The window is closed. The distance is fixed. The only direction is forward. What happens in people, psychologically, when the only direction is forward? Something interesting, actually. Something that isolation researchers have observed consistently enough that it has become one of the more counterintuitive findings in the field. When escape is truly impossible, when the mind fully accepts that there is no way out, a certain kind of suffering tends to diminish. The energy that was spent calculating and recalculating the possibility of return, weighing options, maintaining a kind of background hope for rescue, that energy becomes available for something else. Acceptance, real acceptance, not the performed kind, but the kind that settles into the body, turns out to be a form of relief. Not happiness, not contentment necessarily, but a quieter, more sustainable state than the perpetual low-level anxiety of hoping for something that isn't coming. Viktor Frankl, the psychiatrist who survived the Nazi concentration camps and wrote about what allowed some prisoners to maintain their humanity and sense of meaning even in unimaginable conditions, described something similar. That the last of human freedoms is the ability to choose one's attitude toward any given set of circumstances. That meaning can be found, or made, even when everything else has been taken. His observations were made in conditions of forced imprisonment, of suffering imposed without consent. Mars would be different, chosen freely, entered with full knowledge. But the psychological mechanism he described, the capacity to find or construct meaning within constraints rather than despite them, applies just as fully. The crew on Mars will not be passive recipients of their circumstances. They will be active makers of meaning. Every experiment conducted, every sample collected, every problem solved, every meal grown and shared, every sunrise watched from behind a habitat window. These are not just tasks. They are the acts through which meaning is continuously created and renewed, and there will be sunrises worth watching. 2 of them, in fact, are unlike anything on Earth. The Martian day, called a sol, is about 24 hours and 37 minutes long, almost exactly the same as an Earth day, which is one of those small mercies that mission planners are genuinely grateful for. Because it means the human circadian rhythm, the internal biological clock that regulates sleep and wakefulness, would not need to adapt to a radically different cycle. The difference of 37 minutes accumulates over time, and the crew would likely operate on Mars solar time rather than Earth time, but the basic rhythm of day and night would feel familiar. The sunrise on Mars would be slow, the sky lightening gradually from black to deep violet to the pale butterscotch of full day. The sun, smaller than it appears from Earth, would climb into a sky where stars are still faintly visible near the horizon in the thin atmosphere. The shadows would be long, the light a slightly different quality than Earth light, slightly cooler, slightly more distant. If there were dust in the atmosphere, which there often is, the sunrise would be diffused into something almost watercolour. Soft edges, muted colours, a kind of gentle ambiguity where the horizon blurs into sky. The crew would watch this every morning. Not always. Not in the way you notice a thing that is new, but in the way you notice a thing that has become yours. The way you stop seeing the view from your window and start just feeling it. as part of the texture of the day. That habituation, that slow absorption of an alien landscape into something approaching the ordinary, is itself a profound thing. It means the crew has begun to belong there, not to Earth, not anymore, not fully, but to that place, to that sky, to those sunrises over red ground. It is the beginning of something that does not yet have a name, because no human being has ever lived it. The language for it will come later, after the mission, if there is an after. In the accounts written by people who went and saw and stayed. For now, the sunrise happens, quietly, on a planet that has been waiting for billions of years for someone to watch it, and someone, finally, is watching. The images soften now. The colours are warm and muted. The horizon is somewhere just out of focus. You're almost there. The question of terraforming Mars, of fundamentally altering its environment to make it habitable without spacesuits, is one of the longest-running debates in the entire field of planetary science. It lives at the intersection of the engineering and ethics, of ambition and humility, of what is possible and what is right. The basic concept is straightforward. Mars once had a thicker atmosphere and a warmer climate. If that atmosphere could be restored, or replaced with something breathable, if the temperature could be raised, if water could be returned to the surface in liquid form, then Mars could become, over a very long time scale, a place where human beings could live without the constant mediation of technology between their bodies and their environment. The timescales involved are not short. The most optimistic proposals suggest that meaningful atmospheric thickening could be achieved within centuries, using aggressive methods. More conservative estimates suggest millennia. The most honest assessments acknowledge that we don't fully understand all the variables involved, and that the timescale could be much longer than any current model predicts. The methods proposed range from the plausible to the speculative. Introducing greenhouse gases into the Martian atmosphere to trap more solar heat, a planetary scale version of the same process causing problems on Earth. Redirecting asteroids or comets containing volatiles to impact Mars, delivering water and gases directly. Building orbital mirrors to focus more sunlight on the Martian poles, sublimating the carbon dioxide ice and releasing it into the atmosphere. Seeding the surface with engineered microorganisms, extremophiles adapted to Martian conditions, that would slowly alter the chemistry of the soil and the composition of the air. None of these methods is currently within our technical reach. Some of them, like the orbital mirrors, would require industrial infrastructure in space that doesn't exist, and won't exist for many decades at minimum. But the conversation about them is not purely theoretical, because the decisions made by early settlers about how to use Martian resources and how to interact with the environment will set precedents that shape everything that follows. This is where the ethical dimension becomes unavoidable. If Mars harbours life, even microbial life, even the fossilized remnants of ancient life, then terraforming it means altering or destroying that life's environment, possibly ending it. The question of whether we have the right to do that is not one that science alone can answer. It requires a conversation about values, about what we owe to life in forms we don't fully understand, about whether the imperative to expand human civilization outweighs the imperative to preserve whatever else might be living in the universe. There are thoughtful people on every side of this question. Some argue that microbial life, if it exists on Mars, has no particular claim on the planet that outweighs the potential benefit of a second home for humanity. That the precautionary instinct, while admirable, cannot be allowed to permanently foreclose the possibility of human expansion beyond Earth. Others argue that the discovery of any life beyond Earth would be the most significant scientific finding in human history, and that we have an obligation to study and understand it before altering the environment that produced it. that the same curiosity that drives us toward Mars should make us pause before changing it irreversibly. And there is a third position, quieter but persistent, that asks whether the desire to make Mars more like Earth reflects a kind of poverty of imagination, that rather than transforming Mars into something familiar, we might learn more and become more by adapting ourselves to Mars as it is, by developing technologies and ways of living that work within Martian conditions rather than overwriting them. This last position finds its most interesting expression in the concept of subsurface living. The idea that a Mars settlement might not spread across the surface at all, but instead go down, underground, into lava tubes and subsurface caverns that already exist, carved out by ancient geological activity, that offer natural radiation shielding, natural thermal insulation, and structural integrity that no surface habitat can match. Images from Mars orbiters have revealed what appear to be skylights, openings into subsurface caverns in several locations. The dimensions of these features suggest cavern systems potentially large enough to contain entire settlements. The stable temperatures underground, far less extreme than the surface swings, would reduce energy requirements for heating and cooling dramatically. The rock overhead would block cosmic radiation far more effectively than any engineered shield. A Mars civilization that lives primarily underground, venturing to the surface for work and exploration, but making its home in the deep rock, would be something genuinely new. Neither the Mars of science fiction, domed cities gleaming under an alien sky, nor the Mars of pure survival, cramped habitats and constant emergency. Something in between, something adapted, something that took the planet as it found it, and found a way to live within it. That image, of people moving through tunnels carved by ancient lava, building homes in the bones of a planet, has a quality that is hard to name exactly. Ancient and future at the same time, like cave paintings and space travel occupying the same moment. Humanity has always made its homes in the earth when the surface was too harsh. The earliest shelters were caves. The most enduring structures are those built with the land rather than against it. Perhaps Mars, in the end, will teach us something we already knew and forgot. That home is not a place you conquer. It's a place you learn to belong to. The thought settles like dust on a still surface. Slow, soft, even. Your breath is carrying you now. You don't have to do anything else. Something happens to time when you are very far from home. Not literally, not in the relativistic sense, though at the speeds involved in a Mars mission, there are technically measurable differences in the passage of time that amount to fractions of a second over the entire journey. Nothing dramatic, nothing you would feel. But psychologically, time on Mars would be a different substance than time on Earth. Thicker in some places, thinner in others, stretched across the long, featureless stretches of a soul with nothing new to report, and compressed into nothing during the moments of crisis or discovery when the mind is fully engaged and hours pass like minutes. This is not unique to space. Anyone who has spent a long time in an environment radically different from their ordinary life knows the feeling. Time in a hospital, either as patient or as someone waiting, has a specific texture. Time in a place of extraordinary natural beauty, where attention is fully absorbed by the visible world, has another. Time in grief has another still. The clock keeps its rhythm, but the experience of duration bends around what is happening inside. On Mars, the crew would live in what researchers call a time-compressed environment. Not every day, but over the arc of the mission, the tendency would be for time to lose its ordinary reference points. On Earth, Time is structured by social rhythms, weekdays and weekends, morning routines and evening ones, the school year and summer, holidays that mark the calendar with meaning, the rhythms of a city, the opening and closing of shops, the sounds of rush hour, the particular quality of a Saturday afternoon. None of those structures exist on Mars. The soul proceeds much like the previous one. The weeks, if the crew even uses that unit of time, are not differentiated by social convention. There are no weekends in any meaningful sense, because there is no week in any social sense. There is work, and there is rest, and there is the ongoing project of survival and exploration, and the days accumulate. Some researchers have observed that this loss of social time structure is one of the more disorienting aspects of long-duration isolation. Not because it causes obvious problems, but because it quietly erodes a kind of psychological scaffolding that people don't know they depend on until it's gone. The proposed solution is the deliberate creation of ritual. Not the organic rituals that emerge from social life over centuries, but consciously designed ones, built into the mission schedule specifically to provide the temporal landmarks that the environment doesn't naturally offer. A weekly shared meal where work is not discussed, a monthly ceremony marking another soul completed, a dedicated time each week for personal communication with Earth, however delayed the responses, a regular moment, perhaps at the end of each soul, where each crew member shares one thing they noticed or experienced that day that felt worth sharing. These are small things. They would not replace what was lost, but they would create a kind of rhythm, a way of marking time that gives the days shape and the weeks meaning, in an environment that otherwise offers neither. There is something deeply human about that impulse, the impulse to mark time, to say, this moment mattered, this day was different from the one before, this week has ended and another has begun. It is one of the oldest human behaviours, traceable back to the earliest evidence of culture. The marking of seasons, the tracking of the moon, the alignment of ancient structures with solstices and equinoxes, even on Mars, even alone, even 100 million kilometres from the nearest city, human beings would find ways to mark time, because time is how we tell the story of our lives to ourselves. Without it, experience becomes undifferentiated, and the self begins to lose its edges. The crew on Mars would be, in this sense, doing something people have always done, building culture from scratch, creating the rituals and rhythms and shared meanings that make a group of individuals into a community. It would be the smallest civilization in human history. 6 people, perhaps, or 4. In a habitat the size of a modest house, on a planet with no other inhabitants and no accumulated culture and no traditions older than their own arrival. But it would be a civilization nonetheless, because civilization is not a size, it is a practice. It is the ongoing act of people making meaning together, deciding what matters, creating the structures through which shared life becomes possible. The first generation of Martians, if we can call them that, would be building something whose dimensions they could not yet see. They would be planting seeds, in a cultural sense, as surely as they planted them in the hydroponic systems. Seeds that might grow into something none of them could predict, or they might not. The mission might end without continuation, the habitat eventually going dark, the first and last chapter of a story that didn't find its next page. Both possibilities are real, both deserve to be held honestly. But there is something in the act of planting, regardless of what grows, something in the choosing to begin, knowing the outcome is uncertain. The stars outside don't move. The soul turns slowly toward its end. The habitat hums with the sound of systems doing their work. Inside, someone is writing something down, making a mark, saying, "I was here. This happened. This mattered." Even in the silence, the human impulse to mean something continues. Let that thought be soft. Let it be slow. You're drifting now, and that's exactly right. There is a version of the Mars mission story told in numbers. Launch windows and delta V calculations, habitat volumes and power budgets, radiation doses and mission durations. This version is real and important. And then there is another version, quieter, less often told, the version that lives in the space between the numbers, in the things that don't appear in mission documents but that are, in many ways, the truest part of the story. This is the version about what it means to be the first, not first in a triumphant sense, though there will be triumph in it, but first in the sense of being without precedent, of facing something that no accumulated human wisdom, no library, no tradition has faced before, of having to make decisions and find meanings that don't yet exist, because the situation requiring them has never existed. They will face questions that philosophy has never addressed practically. What do you owe to a planet that cannot ask anything of you? If something goes wrong and someone dies and the mission continues, how do you honor that person in a place where every human tradition of honoring the dead requires resources that don't exist? What does home mean, when home is a metal structure on a planet that has never known life, and the planet you were born on is a point of light in the night sky? What does it mean to have children on Mars? Not as distant hypothetical, but as real question. Because if a settlement becomes permanent, the question of the next generation is not theoretical. It is biological. It is social. It is one of the most profound decisions a community can make. We know almost nothing about human reproduction in reduced gravity. There are theoretical concerns about fetal development, about bone formation, shaped by a gravitational environment different from the one that made us over millions of years of evolution. A child born on Mars would be genuinely different from any human being who has ever lived. Not visibly, perhaps, but in ways that reveal themselves over time, in bone density and cardiovascular capacity, shaped by 1/3 of Earth's gravity. And that child, growing up inside a habitat, learning to walk on a floor that vibrates with life support systems, looking at a sky through a porthole they can never directly feel on their face, that child would have a relationship to Mars that the first generation can never have. Not the relationship of someone who came from somewhere else and chose this, but the relationship of someone for whom this is simply entirely home. There is no word yet for what that would be. A new kind of belonging, a new kind of human, slowly and quietly and without fanfare, beginning. These are thoughts too large for a single night. They belong to the long arc of a story that is only now finding its first sentences. You don't need to hold all of it. These are the kinds of thoughts better drifted through than grasped, better carried into sleep than solved. The habitat hums, the stars are fixed, the soul is ending. Somewhere a point of light that is Earth is rising over the Martian horizon, too small to see without instruments, but there, always there. There is a particular kind of silence that exists only in places where human beings have never been. Not the silence of a quiet room, where absence of sound is defined against the memory of sound. Not the silence of a forest at night, full of biological activity below easy hearing, but a silence so complete and so old it has its own weight. A silence that has never been interrupted, accumulated undisturbed for billions of years. that human voice would enter for the first time like a stone dropped into still water. Mars has that silence, not perfectly, because Mars has weather. Wind moves across the surface, raising dust, shaping dunes. The atmosphere, thin as it is, transmits sound, though differently than Earth's denser air. High frequencies disappear almost immediately. What remains is a muffled, low version of what the sound was, stripped of its upper harmonics. The NASA Perseverance rover carries microphones, the first ever sent to Mars specifically to record sound. The recordings it sent back are extraordinary in their strangeness. Wind moving across the surface sounds almost familiar, but not quite. Something is missing from it. A thinness, a distance, as if the sound is being heard through a wall, or remembered rather than experienced directly. For the crew, sound inside the habitat would be normal. The pressurized environment carries sound exactly as it does on Earth. Voices, footsteps, the sounds of daily life would all be familiar. The strangeness would begin at the airlock. Standing on the Martian surface in a pressurized suit, a crew member would hear their own breathing amplified inside the helmet. The suit's systems, soft mechanical sounds doing their work, their own heartbeat, more present than usual, a reminder of the body's continuous labor. And beyond all of that, very faintly, Mars itself. The low frequencies the thin atmosphere still carries, the subtle acoustic signature of a planet waiting in silence for 4 billion years. There is something difficult to fully articulate about that image. The intimacy of hearing your own heartbeat against the backdrop of planetary silence. The body's noise, small and persistent, in the middle of the oldest quiet there is. Early explorers on Earth, moving into genuinely unmapped territory, described a heightened awareness of the body in spaces where the body had no business being. A sharpening of the senses that comes from an environment where every input is new and must be processed fresh. The crew on Mars would carry this heightened awareness constantly, not as anxiety but as attention, full-spectrum alertness that humans evolved for situations of genuine novelty, genuine consequence, the kind most people living ordinary lives rarely feel. There is a cost to that level of attention sustained over years, a cognitive and emotional tiredness that comes from never fully relaxing. But there is also something that people who have lived in demanding environments describe as what they miss most after returning to ordinary life, a quality of being fully present, of every moment having a weight and texture that safe and predictable environments simply don't provide. The Zen teacher Shunryu Suzuki wrote about beginner's mind, approaching experience as if for the first time, without the filters that accumulated experience imposes. On Mars, beginner's mind would not be a spiritual practice. It would be a survival requirement, every problem genuinely new, every solution improvised, every day requiring fresh engagement that ordinary life almost never demands. That is exhausting, and it is also, in a way hard to fully convey, alive. The thoughts are very slow now. The spaces between them have grown wide and soft. You're in that space, right now, in the gap between one thought and the next. Stay there. It's a good place. The mission has been going for 14 months. The habitat is functioning. No catastrophic failures, though there have been significant equipment problems that required improvised solutions. The crew has settled into rhythms, the work proceeds, the days accumulate. One crew member has developed a habit of going to the observation window at the end of each sol, not to look at anything specific, just to look. She started doing this in the 3rd month, almost without deciding to. It became a ritual before she recognized it as one. What she sees through that window has not changed dramatically. Mars does not offer dramatic daily variety. The same terrain, the same colours, the same quality of light. Occasional dust devils in the middle distance, sometimes thin clouds made of water ice, barely registering against the sky. But she's learned to see it differently, the way you learn to see anything you spend enough time with. She knows which rock formations are visible on the horizon. She knows how the sky looks 1 hour after sunrise versus 2. She has watched the same dune shift very slightly over months, moved by winds she cannot feel from inside. She's becoming a native in the only way a first-generation person can, not by being born there but by paying attention, by accumulating a specific knowledge of a specific place that no one else has, the knowledge that comes only from presence, sustained over time. This is how belonging begins, not with arrival, not with declaration, but with the quiet accumulation of attention paid to a place until that place begins, in some irreversible way, to be part of you. The anthropologist Tim Ingold writes about dwelling, the idea that home is not a location but a practice, that we make places home by moving through them, by incorporating them into our routines, by letting them shape the texture of daily experience until we and the place have become mutually constituted. By 14 months, the crew on Mars would be dwelling there, not as visitors, as inhabitants, as people for whom Mars has become the context of daily life, and Earth, in that context, would be receding, not forgotten, but becoming more like a place of origin than a place of habitation, the way your hometown becomes, after you've lived somewhere else long enough, a place you know deeply but no longer fully belong to. She watches a dust devil form and dissipate in the middle distance, a small local event, lasting perhaps 2 minutes, witnessed by exactly one human being in all of history, and now finished, and gone, and part of the permanent past of the universe. She doesn't write it down. She doesn't need to. She carries it in the way you carry things that no one else will ever see. The window holds the light of an alien afternoon. The soul is ending. She stays a little longer than usual. Then she turns back to the others. Your eyes are heavy. The images are soft and warm. Let the soul end. There is a concept in physics called the event horizon, the boundary beyond which nothing can escape. Cross it and the geometry of space-time itself closes the door behind you. The point of no return on a Mars mission is more gradual, more human. It is the point at which going forward becomes easier than turning back, where the mission has its own momentum, stronger than any individual impulse to reconsider. In practice, this point arrives somewhere in the first few weeks of flight. There is a window, early in the mission, where returning to Earth is feasible though enormously expensive. After that window closes, the mathematics of return become prohibitive, but there is another kind of point of no return that has nothing to do with orbital mechanics. The internal one. The moment when a crew member stops thinking of themselves as someone who left Earth and starts thinking of themselves as someone who lives on Mars. The moment when forward becomes the natural direction and backward becomes the unfamiliar one. The ones who adapt best are the ones who allow this shift to happen without fighting it, who let Mars become home not as a resignation, but as a choice, who understand that identity is not a fixed thing that can only be lost, but a living thing that changes with experience, that becoming someone who belongs to Mars does not erase who they were on Earth. It adds to it, expands it. Every person who has ever moved to a new country, started over after a loss, or found themselves in radically different circumstances knows a version of this. The self you brought with you is real. The self being made by the new circumstances is also real. The relationship between them is integration, the ongoing work of becoming someone who contains both. We are, as a species, extraordinarily good at this. The capacity to adapt, to find new footings, to rebuild identity in unfamiliar terrain is not a special skill. It is a species-wide capability, honed over hundreds of thousands of years of movement and migration. The first people on Mars will be doing what people have always done, moving, adapting, becoming, just farther than anyone has gone before. And somewhere in that recognition there is something comforting, something that reaches back through all the generations of people who left and didn't come back, who crossed oceans and mountains and found new worlds on the other side, and says, this is what we do. This is who we are. The stars outside your window are the same stars they look up at from that red plane. Different angle, different atmosphere, different everything, but the same stars. That connection is real, even across the distance, even across the silence. It is always there. At the edge of sleep, the mind does something interesting. It stops trying to make things make sense. The connections it draws become looser, more associative, more willing to let unlike things exist together without resolving the tension between them. A face appears that belongs to someone you haven't thought about in years. A place you've never been feels completely familiar. Something you were worried about earlier returns briefly, but softer now, drained of its urgency, like a photograph of a fire rather than the fire itself. This is the hypnagogic state, the threshold between waking and sleeping. Artists and scientists have described it for centuries. Edison sat in a chair holding steel balls so that when he drifted into this state and his grip relaxed, the balls would fall and wake him, letting him capture whatever was present at that threshold. The crew on Mars, in the final hour before sleep, would inhabit this state the way everyone does. The day's experiences loose in the mind, not yet sorted into memory but still present, still luminous. The images of a soul spent on another planet drifting through, taking on the strange transformations that threshold consciousness performs on everything it touches. The red plane becomes an ocean, the dust becomes snow, the observation window becomes a mirror showing somewhere green and wet and impossibly lush, a memory of Earth so vivid it has the texture of presence. And then, beneath the images, the body's deeper knowledge, the felt sense of the day, the physical tiredness, real and earned. All of it dissolving now into the undifferentiated warmth that sleep offers to everyone who finds it, regardless of where in the universe they happen to be lying down. Sleep does not know about distance. It does not care whether you're on Earth or on Mars. Sleep arrives the same way everywhere, the same dimming, the same loosening, the same gentle erasure of the boundary between self and everything else. The crew on Mars will sleep. Every soul, if they are lucky, they will find this. The one part of the human experience that no technology can optimize. The one thing that remains entirely animal, entirely beyond engineering. The body lies down, the eyes close, the mind releases its grip on the day, and in that releasing something is restored. A return to the baseline of being alive, before all the categories and concerns that waking consciousness builds around the simple fact of existing. Outside, the Martian night is doing what it always does, holding everything in the dark. The stars are extraordinary, and no one is awake to see them, but they are there. They are always there. Your breath is almost nothing now, just the body doing its oldest work. In and out. There is a letter, or rather, there will be a letter, written before departure, sealed, left with someone trusted on Earth, to be opened under specific circumstances. Every crew member on a Mars mission will have written these letters. Not the technical preparation, not the physical training, but the human preparation, the work of putting into words what matters most, before entering a situation where the opportunity to say those things might not come again. Some letters will be practical, containing information someone will need, the organizational residue of a life that has to be tidied before it can be left. But others will be different. The letters that take weeks to write, that go through draft after draft, because what they are trying to hold is too large for sentences. The letters that try to say what a person means to another person in the accumulated particular details of a shared life. Writing that letter is itself a kind of dying, a rehearsal of the ending, an acknowledgement of finitude that most of us spend most of our lives carefully avoiding. And yet the people who have written those letters describe the experience not primarily as terrifying but as clarifying, a removal of everything inessential, a stripping away of the ambient noise of ordinary life, and a return to the core of what is actually there. Love, it turns out, is extremely clear when you write, as if you might not come back. The crew will receive letters too, voice messages and video messages arriving with a communication delay, always the strange temporal displacement of a conversation where nothing is simultaneous. These messages will be some of the most important objects in the habitat, the evidence that the connection still exists, that the people on Earth are still there, still speaking into the void with the faith that the words will arrive. There will be a crew member whose parent dies while they are on Mars. Almost certain, statistically, the message will arrive with a delay. It will be watched alone, or with crewmates. And then there will be the specific weight of grief in a place where grief has never been felt before. The crewmates will hold each other through the losses that come. The small community of people who have chosen this together, who carry the same distance, who understand in their bodies what it means to be here, unreachable. But other things will come too. The first unexpected discovery. The small miracle of something growing where nothing was supposed to grow. The morning someone wakes up and realizes, without having planned to, that they are happy. Not in spite of where they are, but because of it. The letter was written and sealed and left behind. The mission is what remains, one soul at a time. The body is very still. The room is very quiet. Just the breath, moving in, moving out, like a tide, going nowhere in particular, just moving, because that is what it does. Mars will be colonized, or it won't. From inside the present moment, it is impossible to know which direction history will move. But something has already happened that cannot be undone. Something that does not depend on whether the first crewed mission launches in 10 years or 30, whether the habitat functions or fails, whether the first people on Mars ever find their way back. What has already happened is the imagining of it, the sustained, serious, technically detailed imagining of human life on another planet, not as fantasy, as a concrete engineering problem being worked on right now by thousands of people with the specific intention of making it real within the lifetimes of people currently alive. That imagining changes something, not just about space exploration, but about the human relationship to possibility itself. Technologies developed for Mars find applications on Earth. Water recycling systems adapted for water-scarce regions. Lightweight insulation, improving building efficiency. Medical monitoring deployed in remote communities. The problem of keeping people alive in extreme environments, solved for space, has versions that apply in deserts, in disaster zones, in the high Arctic. Children alive today will live to see it, will watch from wherever they are on Earth as a small group of people descends through a butterscotch sky, lands on red ground, and takes the first steps of a new chapter in the oldest story our species knows. The story of going somewhere no one has been, of finding out what's there. Those children will grow up in a world where Mars is not a dream but a known place, a place with a human history, however short, a place where specific people lived and worked and looked up at a specific sky and felt specific things they later tried to put into words. That world will be different from this one. The problems of Earth will still be the problems of Earth. Mars will not solve anything that is wrong here. But the sense of what is possible will be larger, will contain a knowledge earned through doing, undeniable, that when we choose something hard enough and work toward it long enough, we can do things that previously existed only in imagination. The first people on Mars will carry that knowledge into the universe, in their bodies, in their choices, in the simple fact of being there, and here, on Earth, in the long quiet of a night moving toward its end, that fact exists as something worth knowing, as a light at the far edge of the possible, distant but real. Even as the eyes close, even as the thoughts dissolve, it's always there. And so we arrive at the end. Not Mars, not the habitat, not the red plain under the butterscotch sky, but here, this moment, where the story has said what it came to say, and the silence that follows is a different kind of silence than the one before it. A fuller silence. A silence that has been earned. You have travelled a long way tonight, not in kilometres, though the distances involved are so large the numbers stop meaning anything useful, but in the other kind of distance, the kind measured in ideas and images and quiet recognitions, the kind that leaves you somewhere different than where you started, even if you haven't moved at all. The first humans on Mars will never come back. Perhaps, or perhaps they will, in some future where the technology has caught up with the ambition. The title of this story is a question as much as a statement, an invitation to think seriously about what it means to go somewhere from which return is uncertain, about what we owe to the people who go, about what they carry on our behalf. Because they will carry something on our behalf. They always do. The people who go first, the dreams and the fears and the questions of everyone who stays behind. The species' oldest impulse, wrapped in the most modern technology we can build, and we carry them in the attention we pay, in the care we extend across the distance, in the willingness to let the story matter. Even though we are here and they are there. Tonight you have spent time with one of the largest questions the human species is currently living with. You have let it move through you slowly, the way stories move through us when we are close to sleep. Not as argument or information, but as something more like music, something felt more than understood. Before you go, one last thing. If this story reached you tonight, if it accompanied you somewhere on the journey towards sleep, if it made the large things feel large and the quiet feel quiet, then it did what it was made to do. Leave a comment. Tell me where you are in the world. Tell me what time it is there. Tell me if you fell asleep before the end and had to come back, because that is not failure. That is exactly what this was made for. Subscribe if you want more nights like this one, more long, slow journeys through ideas that are too large for ordinary conversation but fit perfectly in the dark. When the body is still and the mind is soft, this is sleep space, And tonight, as always, you are welcome here. Outside, the Martian night holds everything in its ancient silence. The stars are extraordinary. The Milky Way arcs overhead in full clarity, seen from a place where no human eye has ever rested on it before, and somewhere, barely visible, a point of light that is Earth rises over the eastern horizon, small, steady, blue, still there, always there. The breath moves in and out, and the night holds everything, and you are already, almost, gone